All right, for this bell work, there is a little distribution on there, so we're gonna have to do that first. And remember, this is, it's not just a 9 that we're going to distribute, it's a -9, okay? So the -9, you can see the phantom 1x if you'd like to show it. You don't have to, but you can. But when I distribute this to the first term there, that'd be -9 groups of 1x, which results in -9x's, okay? Then we gotta distribute, remember distribution is multiplication. We gotta distribute that -9 to the +2, so that'd be -9 times +2, which is -18. Okay, we didn't do anything with the 5x plus 6 because there was no distribution there, okay? So this is my new expression. But now I look to combine any like terms, and there's only 2 different types of terms. You got x terms and constants all throughout. So I should only end up with 2 separate terms in the end. So I'm gonna look first at the x terms. You got 5x's and -9x's. How many x's would that be? Well, that'd be the same as 5 minus 9, which I recommend putting in the calculator. A lot of students have not been doing that, and they've been making the small mistake of either it being positive or negative, or just calculating it incorrectly. Put that in the calculator, you get -4. Okay, so I got -4x's, and then I can combine my constants, 6 and -18. So again, that would read as 6 minus 18 in the calculator, which comes out as -12. So this would be the expression that would work. Of course, if you switch the order on this, it'd be fine, just as long as each term keeps its sign. So -12 and -4x. Of course, it reads as -12 minus 4x, but the minus sign is the negative sign for the 4x term. Okay, so either one of these will work, which we're pretty much going to be seeing the same thing today with this distribution and then combining like term stuff. Okay, so as long as you can do this, then the lesson today will go very well. So there's our objective. I can simplify expressions that are being added or subtracted from each other. Take 30 seconds and copy that down, please. All right, adding expressions. So these two are a little bit different, okay? Adding expressions, and you can look at it like you're distributing in both scenarios, but you have to remember that you're when you're using subtraction with expressions that you're going to be distributing, okay? So we're going to be starting with just adding the expressions. So adding expressions is pretty much the same as combining like terms, although what we end up doing here is distribute phantom 1s. Okay, and as long as you understand that we're distributing phantom 1s and then combining like terms, then this becomes, you'll see that this becomes fairly simple, okay? So on an example like this, we got 2 expressions. You got this expression here, -4x plus 10, and then you got this expression here, 3x minus 7. So there's parentheses, okay? So we should be looking for some distribution at this point for both sets. And the question then becomes, what are we distributing? Well, that's when we look at this as we're distributing a phantom 1 here in both scenarios, okay? So right here, it'd be like saying you got 1 group of -4x's, and then how many x's is that? Well, 1 times -4 is -4. So that's -4x, and then you also have this 1 times 10, which results in +10. So remember, that's +10, so I show that as +10. Now over here for the second one, I'm distributing this one to the first just the 3x, so that's 1 times 3x's, which results in +3x. So I do need the plus sign there to indicate that this term is positive 3x. And then I distribute the 1 to the -7, so that's 1 times -7. Remember that distribution is multiplication, so that's why we're multiplying these. 1 times -7 is -7, okay? Now that I've distributed those 1s, I look to combine any like terms that I have, and I see I got some x terms here. So how many x's would that be? You'd have -4 and then plus the 3, which would result in -1 x's. And then also, you got constants of 10 and -7, so that'd be like 10 minus 7, which is +3. Now on Canvas, I would make that a phantom 1. Okay, so this is kind of how I would put it into Canvas, -x plus 3. The 1 is there, it's just a phantom 1 now, you can't see it. Of course, if you wanted to change the order, that'd be fine as long as your signs remain the same. positive 3, and negative x. Either one of these would work in Canvas. Now, the last thing I'm going to point out on this one is, if you look at what we started with and what we ended up with after the distribution here in red, really all we did was we took away the parentheses, okay? And that's what it said on the last slide. When you're adding expressions like this, because 1 times anything is just itself, whatever you're multiplying the 1 by, right? Like 1 times negative 4x, it was negative 4x. 1 times 10 is 10, and so forth, okay? So whatever you multiply by 1, you get the same thing back. So it's like, it's almost like we could have went back to the beginning here and said, well, what we could have just done is said, I don't want the parentheses. And that would work. As long as you're looking at addition. You have to be looking at addition though. So what I'm trying to say here is, like this one, we see addition of the 2 parentheses. Now you're welcome to do what we did on the last one, put some phantom 1s there, but really all we need to do at this point is get rid of the parentheses. Okay, and then we're looking at a combining like terms problem, okay? Now, like I said, you could distribute the 1s, and if that helps you to do that, then do it. Okay, because once we start subtracting, we're going to have to do the distribution. But if you're adding, you don't necessarily need to. So I would look immediately for any terms that I can combine like terms. So I even see the x, I would want to show that phantom 1 now, because I'm going to be combining that x, this x term with these 10x terms, okay? So 10x's and 1x's. So that's like 10 plus 1, which is 11x's. Then I got my constants, negative 6.1 and positive 4, so I'd do negative 6.1 plus 4 in my calculator, which gives me negative 2.1. And that's it. This is as far as we need to go on a problem like this one. Of course, if you wanted to change the order, that's fine, negative 2.1 and then positive 11x, as long as the signs remain the same for each term. Either one of these will work. So the problems that are like this on the assignment, it has 2 parts. Okay, so let's read this. Write a linear expression in simplest form to represent the perimeter of the triangle below. So that's one part. So we're going to find an expression. The second part says find the perimeter if the value of x is 2. So this goes back to, I think it was earlier in this unit, right, where we were evaluating expressions. It tells us the value of x that it wants. Okay. So one of the key words that we see on this problem is the word for perimeter. Perimeter is where we take all of the side lengths on the outside of the whatever shape it is. This one's a triangle, although I think the one on the assignment is a rectangle. But then you take all of these lengths. So like this one right here, which is 4x, we're going to take that length, and then we got this other length, because I'm just going around the edges here, which is, it's in parentheses, 12x minus 20.3. And then this bottom length right here at 4x plus 8. Since this is perimeter, as we've seen, that means I'm just going to add these values together. That's it. Now what we saw in that last problem is that since this is a perimeter problem, I can just pretty much get rid of the parentheses because we're just adding the values, okay? If there was any subtraction, then I would have to distribute what will be a phantom negative 1, but we'll see that on the next problem, okay? Now, even at this point, you could say I'm going to replace the values of x's with 2's and then solve there, but if I simplify it, it'll just be a little bit easier for us. So that's what I'm going to look to do. I got 4x's, 12x's, and 4x's. How many x's is that? So that'd be 4 plus 12 plus 4, which results in 20 x's. Then we also got, let's see, we got the constants, negative 20.3 and then positive 8. Okay, so that'd be negative 20.3 plus 8, which results in negative 12.3. So this would be one of the answers for us right here. It's one of the expressions. It's the first answer that we would have. And yes, if you wanted to write it down in the other order, that would be fine. Where you got the negative 12.3 first and then the positive 20x. That's fine. Okay. But now we want to actually find the perimeter if the value of x is 2. So I'm going to write this out. I'm going to use the one that I have boxed in, 20x minus 12.3. But up here it says the value of x is 2. So I replace the x here with 2. And see, it's just less calculating than what would have originally been up here, replacing those x's. Although you should get the same answer. And by the way, I'm going to let the calculator pretty much do all the work here for me, okay? So I go to my calculator, 20 parentheses 2, close parentheses, minus 12.3, enter. And the calculator tells me that when this is simplified, it ends up being 27.7. And that would be my second answer for this problem, okay? Two different answers for this same problem. So, like we said before, adding expressions is the same as just combining like terms because we can pretty much get rid of the parentheses. Once we start looking at subtracting expressions, then you have to remember that you're going to be distributing a -1. Okay, then, only then can you combine your like terms. Just like you will when you're just simplifying expressions generally. Like we did on the bell work, you have to distribute first, and then you can combine like terms. But it's the -1 part here that you have to be careful about because in these expressions, you're going to have an expression here and then an expression here, but you're going to see subtraction in between. It's this -1 here, it's talking about with that minus sign. A -1, then you distribute that into your parentheses. Okay, whatever's inside there, you distribute, multiply the -1 by those terms. All right, so for this problem, you can look at this as kind of a 1 that you're distributing into this first set of parentheses. Remember, 1 doesn't change anything. Multiplying by 1 doesn't. So 1 times 6x, still 6x. Or 1 times 8 is still positive 8, and we show that as plus 8. It's the -1 here from the minus that is important. -1 times 7 is going to change that to -7, and then -1 times 8x's would result in -8x's. See how it changes that sign right there from a positive 7 to a -7, a positive 8x to a -8x. That's what we get from distribution of a -1 right there. Now that we have that, we can look to combine the x terms, the like terms. So 6x's and minus 8x's, that would be -2x's. And then we also have 8 and -7, so that'd be like 8 minus 7, which is positive 1. Okay, so that's one way to write this. Of course, you can kind of switch that up and make it positive 1 minus 2x. Remember, you just got to keep the signs the same. -2x needs to be -2x. Positive 1 needs to be positive 1. All right, you guys try this one out. Take a minute, try this one out, then we'll go over, okay? So just like we saw in that last problem, you can kind of look at this as a phantom 1 here that you're distributing. And the nice thing about multiplying by 1 is it doesn't change the value. It's the identity property of multiplication. So it's like 1 times 10x's. Yeah, that's still 10x's. Okay, or even 1 times -6.1. That's still -6.1. It's this minus that makes this a -1 that distributes. That does change things, okay, because it's now a negative. And it may help you to see that 1 right there with x, that phantom 1. Okay, so it's like -1 times 1x's. Remembering that distribution is multiplication, so -1 times 1x would be -1x. And I'm going to keep this 1 here instead of making a phantom 1 because I know I got another x term to combine it with. Then I also have -1 times 4, which would be -4. Okay, now that I have that, I am ready once again to start combining like terms. I got my x terms here. So it'd be 10x's minus 1x's, which is 9x's. And then we also have the constants, -6.1 and then -4, which is -10.1. So that would be the expression that we'd want. Of course, you could rearrange it with -10.1 first, and then the positive 9x second, okay? Now you'll notice this problem, if you go back to the addition problem that we did, it was the same problem, it just had addition between. We get a different answer on this because it was now subtraction. If it was addition like we saw when we were doing addition, then we see that the answer is different, okay? But it's pretty much the same problem, just showing subtraction. That's crucial to notice that the signs are different there, because it then becomes a different problem. So there's our objective. I can simplify expressions that are being added or subtracted from each other. Really the key one here is subtraction, because when it is subtraction, you have to distribute a -1 into that set of parentheses.